डाल देता हूँ आपको ना। अब नीचे में सॉरी गुड।
Interesting webinar series which we do every month. The purpose of this webinar series is to create awareness about the latest technologies or to carry out the course correction, what are the things where we are lacking, and what are the emerging trends, so that the awareness and the capacity is built, and the problems which are related to road construction and other issues can be properly addressed with the help of our experts in this field. Today we have a very relevant topic and two very good speakers who are expert into on the subject matter, and they have their expertise more will be spoken by Dr. V. Raghavan. Let me just very briefly tell about our uh, Professor Raghavan. He is a person who doesn't need any introduction in the our ecosystem. Rodi, almost everybody knows about Professor Raghavan. But the Professor Raghavan very recently retired as a professor in civil engineering from IIT Madras. He has over 44 years of experience in teaching and research. He is a member of several technical committees of Indian Road Congress, received several awards from IRC, including Pandit Jawaharlal Nehru Bus Centenary Award, received IST National Award for CIDC Vishwakarma Award, and has published over 250 papers in the journals and the conference proceeding. He is co-author of 5 books in civil engineering and a fellow of Institution of Engineers India and International Society of Engineering and Asset Management. Ladies and we are privileged to have him as a moderator for today's talk, and the two experts who are going to talk today. One, Dr. Shubham Kalur is a person from the industry with a lot of background knowledge, and actually what are things being done on ground. He will be sharing his experience. Then we have Professor Digvijay
Dharamveer Singh.
Professor Dharamveer Singh from IIT Bombay. He is another expert into the highway construction, road design, designing, and the flexible payment. We have been in touch since long time. So very recently, I heard his talk in NHAI, where he addressed more than 600 engineers, the highway contractors, consultant, and the NHAI officers. That was very well appreciated. So we are fortunate to have him today with us. And the topic today, which they will be talking about, again, very, very important topic, generally, which is nowadays being missed, is the road construction and the stabilization. Stabilization is a very, very important area, though it's a age-old practice. And there it used to be, in fact, at initial in our engineering colleges time, this used to be a topic. As a backbone, the people there, that this is when you're most of the highways are being constructed on embankment. This is one of the area which should be, but there are many reasons why these are not being practiced very well, or somewhere we are lacking. Maybe the policy integration not actually leading it to properly. That can be one thing. The cost benefit analysis and the training, the skilling as a part of this. What we are going to talk today on this, lack of incentivization for the good soil stabilization and use of local material and innovation into this field. and monitoring and case studies. So these are some of the topics which are related to the stabilization. And very recently, there has been a lot of news. It was viral in social media when people were showing the wavy kind of roads on some of the major expressways or the recently constructed road. These are all failures, basically, if we think not properly stabilized, and then ultimately leads to things. So what should be done? What are the various studies our experts will be talking? And the session will be moderated by none other than Professor Dr. V. Raghavan. So without taking much time, I hand over the stage to Dr. Raghavan to please moderate the session, introduce our speakers, esteemed speakers, and please take on it. At the end of these two speakers, they are half an hour, though we are not doing justice, just giving half an hour to such a stalwart speakers on these. But considering the time constraint, I'm sure they will be giving you the concentrated knowledge in this. There will be another 15 minutes. We have interactive question and answer session. And then finally, it will be concluded by Dr. Raghavan. Over to you, Dr. Raghavan.
Yeah. Thank you, Mr. Akhilesh. I think Mr. Akhilesh has given an introduction on the need and importance of the topic. So let me not go into the need and importance of the topic. Let me just introduce the speaker at this point of time. Dr. Shubham holds a PhD in civil engineering from the Indian Institute of Science, Bangalore. Currently, he is working as a technical manager at Zydex Industries Private Limited. His research mainly focuses on advancing pavement engineering through innovative nanotechnology applications. He has been recognized with prestigious award from IGS, Professor T.S. Nagaraj Memorial Research Award, and the Prime Minister Fellowship for Doctoral Program. So as rightly mentioned by Akhilesh, it's not a new topic of stabilization to be adopted in the country. We have enough codes, guidelines, best practices, all are available there. So, but still, we are not adopting, or very rarely we are adopting. What are the issues or concerns? Perhaps we can discuss at the end. I can hear from the participants what is preventing us from adopting this technology. Of late, we have been adopting a full depth reclamation in a very large scale in Uttar Pradesh. I think Dr. Dharamveer will share more about recycling and full depth reclamation. In this talk, Mr. Shubham will present about the overview of the stabilization practices using Indian standards. What are the key issues, considering the critical factors for designing the stabilized payments? He will also talk about the importance of water in the design of payments, stabilized bases and sub-bases. He will also talk about the performance of the stabilized layers through using falling weight deflectometer. And he will also share case studies and research findings to demonstrate the effectiveness of long-term benefits of stabilization. So let us hear from Shubham, and then we can discuss further at the end. Over to you, Shubham.
Yeah, thank you, sir, for the kind introduction. I'll share my screen. So can you please confirm if my screen is visible?
But the side, yeah, fine, go ahead.
Yeah, thank you.
You can take about 30 minutes time.
Yes,
yeah,
thank you, sir.
Yeah.
First of all, I would like to thank the International Road Federation for Indian chapter for giving this opportunity to talk on the topic, stabilization in payments, design, performance, and economy. I'll try to touch upon few of the points listed in this webinar title. I'll briefly show about the performance, economy, and I'll list down the few points why we are not routinely using these methods and what needs to be changed for future works. So let me start with my presentation. I'll briefly introduce the stabilization methods, the mixed design and payment design using our IRC specifications, the issues and potential solutions that are there in the stabilization of payments. And further, I'll be discussing on the performance of stabilized payments that has been constructed over from long time by Zydex Industries. And also I'll be discussing further ongoing research and developments that we are doing at Zydex on the development of the stabilization and how we can improve further the design and have a durability for the payments. Further, I'll conclude this presentation with few remarks. So we need to construct our pavements and the future pavements by considering these three important points. That includes, we need to have our pavements climate resilient, that it needs to sustain the changing climate conditions. It needs to be cost effective, as well as we need to satisfy the sustainability development goals that are led by UN missions. So why stabilization is needed? Basically, we are right now mining and hauling the road construction that disturbs the ecology and environment. We need to construct with marginal materials and soils. Also, we need to recycle the existing crust material so as to achieve the cost effectiveness as well as the sustainability goal. We need to increase the service life of pavement with increasing traffic demand and changing climate. That means we need to address the climate resilient conditions. So stabilization is a technique to improve the properties of soil and pavement layers. We have two types of stabilization. The first one is mechanical stabilization, in which we add granular material and compact it. This technique is related to the correction of a grain size distribution so that we can have a maximum packing density and minimize the void contents. The second method we have is chemical stabilization. In this, we use the binders such as cement, lime, as well as in conjunction, we use chemical stabilizers such as silane-based, or even we can use polymers. So the benefits for stabilization includes the solution for problematic or soft soils where we are not able to satisfy the CBR greater than 5 condition. If there are failure with respect to the surface deflection, these problems are related to the pavement foundation, inadequate subgrade or base or sub-base strength conditions. Also, in many cases, it is required to reduce the plasticity index. So the stabilization works very well. Also, in the conditions where we have prolonged monsoon seasons or stagnant water, in that case, we need to increase the durability of stabilized layer. So in addition to this, we can also reduce the thickness of bituminous layer. This is because we have a higher strength for the stabilized layer compared to the unbounded materials. Talking about the specifications for design, we have two specifications. The first one is IRC SP 89 2010. The title is Guidelines for Soil and Granular Material Stabilization using Cement, Lime, and Fly Ash. So this guideline is basically for the conventional stabilization agents such as cement, lime, and fly ash. The second one is the amendment to the first one, which was released in 2018. It is IRC SP 89 Part 2. The title of this guideline is Guideline for Design of Stabilized Pavements. So this was specifically developed for the use of commercial chemical stabilization with and without conventional stabilizers. In market, we have numerous chemicals stabilizers. To name few of them, we have natural inorganic powder binders, silane-based chemicals, waste oil, petroleum-based product, liquid stabilized product, synthetic polymers, and sulfonate lignin. Talking about the mixed design for stabilization, here our objectives are to provide adequate strength and durability to the pavement. We should have a construction ease and as well as economy. The guidelines specify two requirements for the design, and that is the testing requirement. The first one is the unconfined compressive strength test based upon the cubical or cylindrical sample. The second test is the durability in order to check the impact of water. In this, we have the drying and wetting cycles, 12 cycles we do, and then measure the amount of mass loss after each cycle. And also we report the UCS under dry ratio of wet to dry UCS as a residual UCS. Now, talking about the pavement design, the most important parameter for the pavement design includes the resilient modulus. We need to give the 3 inputs to the IIT pave of each layer. That includes the resilient modulus, its Poisson ratio, and its trial thickness. Based on that, we can do the stress strain analysis, and then using the distress functions, we can find out the adequate pavement layer thickness. So the guidelines suggest the resilient modulus depending upon what type of hardening chemical stabilizers we are using. For a rapid hardening, the guidelines suggest to use a multiplier of 1000 multiplied by UCS. That will give the resilient modulus for the base layer with a rapid hardening CS. For slow hardening CS or CCS, the guidelines suggest to use a multiplier of 750. Further, for design, we need to consider 20% of the MR value calculated using these two equations. If we are measuring the modulus using 4-point bending test, we need to consider a safety factor of 1.5. For flexure strength, we can take directly 20% value of UCS and use that value for the fatigue analysis. Now, for the specifications for the stabilization, first for the base layer, we need to achieve the UCS in the range of 4.5 MPa to 7 MPa. The laboratory strength shall be 1.1 times higher than the design strength. Also, there are upper cap on the modulus value that we can consider. For the modulus value based on the UCS, the empirical relation, we have upper cap of 1400 MPa, whereas we have upper cap of 1700 MPa if we do the beam testing. For also, the guidelines suggest to do the flexure and cumulative damage analysis suggested by IRC 37, 2018. For the subbase layer, the UCS needs to be in the range of 0.75 MPa to 1.5 MPa, whereas the modulus value shall be 400 MPa for the design. Now, I'll be listing out few of the issues or cautions that one needs to consider while designing the stabilized pavement. The first issue is the empirical equations that we have adopted for the calculation of resilient modulus, that is the multipliers 750 and 1000, are valid for high quality crushed rock or natural or non-plastic soils. Also, the Ostrov recommend that there's a high variability in the empirical equation, and therefore they recommend to measure the modulus using 4-point bending test. So the multipliers that we are using currently, those are not valid for soil aggregate mixtures with a PI of less than 20 for subbase and for less than 10 for the base layers. Therefore, it is recommended to measure the flexure strength and flexure modulus using a 4-point bending test. Now, there's an appendix in IRC SP 89, which talks about the measurement of modulus using 4-point bending test. But the guideline recommends the measurement under static or monotonic loading conditions. Also, the formula for modulus needs correction as it does not consider the deflection or strain value while calculating the modulus. Therefore, it is important to measure the flexure modulus using a 4-point beam test, considering the deflection as well as under a repeated loading conditions. This is important because the flexure fatigue models, those are developed considering the modulus under repeated loading. The modulus that we get from the monotonic loading as well as under repeated loading may not be same. So this is the one of the equation as suggested by Ostrov AGPT T600. In this equation is for the modulus calculation, and it considers the repeated loading as well as the resilient deformation that we get through the repeated loading. Further, talking about the fatigue models, the fatigue equations recommended in IRC 2018 are developed by Ostrov and Ostrov for base layer materials for non-plastic soil, as indicated previously also. Their gradation limits are more stringent. They follow Fuller curve, and as well as the allowable limits are within very narrow range. But whatever the specifications laid in the MORTH are quite wide. Also, the fatigue equations are not applicable for the soil aggregate materials with PI in the range of 5 to 10. Therefore, we need to develop our own fatigue equation for both conventional stabilizers as well as for the conventional chemical stabilizers specific to the material specifications used in India. Further, we also need to consider the impact of moisture on modulus. For the subgrade, we consider the 4-day soaked CBR. This is considered in order to simulate the worst case scenario that can happen in the field. But for the stabilized layer, are we really considering any the correction for the modulus layer, or are we measuring the modulus under wet condition is a questionable. What the current framework right now we are following is we are measuring the UCS in 7 or 28 days, depending upon the hardening agent that we are using, and then using empirical equations or by using the 4-point bending test, we are finding out its elastic modulus and then putting into fatigue models and getting the life of a pavement. But in this, we are not actually capturing the effect of wet condition in the analysis. There's a 20% correction factor that is considered, but does it really account for moisture or does it account for other variabilities? That is questionable. Also, we have a durability test that accounts for the moisture impact, but durability measures the mass loss. That is, it is really abrasion resistant and does not measure the material stiffness in wet condition. Our pavements undergo 90 to 100 days of monsoon. Therefore, modulus in wet conditions should be considered in the design. Now, talking about the impact of water, we have multiple sources of infiltration in pavement. That includes the surface infiltration through the cracks, shoulders. We have the bottom of infiltration through the capillary action also, and there could be a side infiltration due to agriculture fields or adjacent canal. So this water leads to the degradation of modulus of structural layer that eventually leads to the weakening of the pavement layers, its bearing capacity, and eventually leads to the formation of potholes, leading to the failure of pavement. Now, the solution to this problem is water-resistant pavement, where we can adopt the organosolvent chemistry to reduce the moisture damage. So we have the solution for the all layers of pavement, but I'll be focusing in this talk on the bases, sub-bases, shoulders, and subgrades stabilization. So what are organosolvents? Soil as an inherent has a water-loving nature where it just absorbs the water as soon as it comes in contact. But after treatment, it can repel the water as shown in this figure. Actually, soil has a surface nature of OH groups, which make them hydrophilic, water-loving. It consists of a silanon groups as shown in this figure. So due to this, there happens to be a continuous absorption of water that leads to its reduction in the modulus. Now, once we treat it with the organosolvent additives, what it does is we create a hydrophobic zone, water repellent zone. So the thickness of such layer is almost 4 to 6 nanometer, and this is a alkyl siloxane surface that gets formed above the soil surfaces. So essentially, this reflects in the water repellency, and whatever the capillary action or the water infiltration that was happening, that gets reduced. This reduces the water ingress into the pavement layer, which can reflect in the retained its modulus value and even under wet conditions. Now, what is the value addition that these chemicals are adding? We have two chemicals that goes in conjunction. The first one is the terrasil and the next one is the zycobond. Terrasil essentially gives the water resistivity, while the zycobond gives the modulus enhancement and nanobonding. So the combination of water resistive and modulus enhancement gives the higher retained UCS. The combination of moisture resistivity and nanobonding gives the higher dry wet durability cycles, whereas the combination of modulus enhancement and nanobonding gives the higher UCS, either 7 or 28 days. The combination of all this 6 gives you the longevity to the pavement, which gets reflected into the higher fatigue life. So what we are trying to give is the resistance to deformation, water resistivity, and fatigue performance improvement. In order to understand the impact of moisture, what normally we have is a subgrade soak condition that we consider in our pavements. But to simulate this condition in the lab, I'm trying to just show, like, if we have a stabilized base layer and a bituminous layer and a subgrade, which is like a subgrade under submerged conditions, this condition can be simulated in our lab by just keeping a cube sample on a porous stone, which is submerged under water. Now, what happens is that it has since this is a soil plus aggregate mixture, it has a tendency to absorb water. This absorption of water leads to the further issues and the water damages related to water. So this is one of the pictorial view from our experiments that we are doing. The porous stone, the cube is kept on the porous stone, which is under water bath. And here you can see due to the capillary action, the water has taken up by the sample. And depending upon the additive or depending upon the cement content, the capillary uptake varies. So this is another slide where I'm showing with only cement of 5%. We can see after 24 hours, the capillary uptake is significant, where the water has gone up by almost 75, up to its 75%, 3/4 of its height. And as we add the water repellency additives, that is terrasil and zycobond, the water uptake gets reduced as the dosage increases. For this figure, we have a dosage of 0.75 kg per meter cube each terrasil zycobond. And for the last figure, we have the dosage of 1.5 kg per meter cube. So this is just a visual representation, but what happens on its strength? So this is reported in terms of the unconfined compressive strength. So let's say we have done the regular UCS casting, and after 7 days of curing with only cement, we get a UCS value of around 3.9 MPa. But after 24 hours of capillary intake, and then we measure its UCS value, it gets dropped down to around 1.4 MPa, which is significantly less than almost less than its 50% value. But we can retain this value by adding organosilane additives such as terrasil and zycobond. Here in this figure, we can see at a dosage of 0.75, we can almost increase the value by 19%. With a higher dosage, we can retain the value by 97%. Further to moving on to the next section, that is on, I'll not go into details, but just briefly touch on the construction methodology for the stabilized pavement. So we have two types of construction methodology. One is the WMM plant-based and the other one is recycler-based. So the steps are just shown in this figure, which includes the preparation of mix, then transportation and laying, further the compaction, curing, and then the finished surface for the stabilized layer. Similar this we can do in a much more proper way by using a recycler. This includes cement or additive spreading at the first layer, and then water and chemical additives addition, and then in situ recycling of the pavement layers. Further, it consists of a rolling and grading as per the camber requirements, and then the final compaction using PTR and vibratory rollers. So these are the first few photographs that from the UP full depth reclamation that we have done. Just a repetition what I said in the last slide. And now talking about the performance of stabilized pavements. So I'll be talking about the performance post construction of this pavement. So these are the few pictorial view. Here we can see this is from the full depth reclamation in UP, where you can see the water is like adjacent to the road from the both sides, and it is under completely submerged condition. But still the pavement is performing very well, and it is actually giving the water repellency, and it's maintaining its modulus value. Further, the technology works in case of heavily frost and few regions where we have the you can see the snowy regions completely surrounding the pavement layer, but still it's performing under good conditions. In both the conditions, what we have done is we have replaced the aggregate by almost 77% and have used marginal soils or borrow materials which are available locally. Further, this is another project from Karnataka PMGSY road. Here we can see after 3 years, there's almost any degradation that has happened, and the pavement has been performing very well, even after 3 monsoon seasons. Further, now I'll be showing few of the results from the FWD test that we have done on the full depth reclamation packages in UP. So we have evaluated almost 20 roads using the Co-op FWD machine, which applies a dynamic load, standard dynamic load of 40 kilonewton, and on a bearing plate. And we have a geophones at a distances of 200 mm, standard offsets of 200, 300, 450, 600, 900, and 1200 mm. 1200 mm, and then we measure the deflections at these locations and then find out what is the deflection bow. So these are the few of the results from the testing. These are the deflection balls. Right now in this, I'm just showing the deflection corresponding at the loading point, deflection corresponding to 300 mm offset, and deflection at 1200 mm offset. So in this graph, you can see on the y-axis is the chainage. So it depends upon the length of the road, and on the y-axis, we have the deflection reported in mm. This figure shows that there's a high variability in the deflection data, or here what you can say is the deflection can vary within a few meters, like let's say here the maximum deflection was 0.3, but at the next change it is 1.15. So due to this being in place stabilization method and wide variation in the gradation, that reflects in the huge variation in the deflection data. So this is corresponding to UPFDR package ID 187, but similarly for just few candidates, I'm trying to show the raw data from the FWD testing. So overall, what we can see, the deflection at the point of loading varies between 0.1 mm to around 0.6 mm. Sometimes wherever there has been poor conditions or localized failure, the deflections can even go up to 1 mm. But overall, what we can see, the deflection is around 0.5 mm. This data is pre-monsoon, like it is before the monsoon season. We are also taking the readings after the monsoon season. Right now, the evaluation is in progress, just to understand what is the correlation between under the wet conditions. Now, talking about the FWD back calculation procedure. Now, IRC, we have a code IRC 115, which is practiced for the FWD back calculation procedure, but it is specifically developed for conventional unbound materials. It is based on 3-layer system, that is surface layer, base layer, combined base and sub-base layer, and the subgrade layer. This software recommends KGB back software for back calculating moduli. Now, for applicability to the semi-rigid pavement depends on this input seed moduli and the convergence that is taking place. But the issue is KGP back does not directly output the goodness of fit or quantify the relative error during convergence of a deflection ball. This issue can be addressed by giving a seed moduli, by iteratively changing the seed moduli to ensure proper convergence, or else by comparing the KGB back's deflection ball with the IIT PAVE. That means we can, the modulus that we have calculated from the KGB back can be put into IIT PAVE and then finding out the surface deflection corresponding to the offsets that we have considered. And then by comparing the two deflection balls, we can measure the relative error in terms of the root R square, or also we can consider the root mean square error. Now, let me illustrate the problem associated with the FWD back calculation. So let's say we have measured the FWD bowl using the WAB machine, which is shown in the red line in this figure. So on the y-axis, I have the deflections, whereas on the x-axis, I have the geophone offsets. Now, if I consider the seed modulus, which are based upon the models that we are considering, that is the multiplier of 1000 and 750, the relation between the resilient modulus and the UCS, what I get, the expected range of the base material will be 4500 to 7000. Or it could be around, if I consider the 750 multiplier, it will be 3375 to some value. And for the BC layer, it will be 750 to 3000, which is recommended by IRC 115. Depending upon the visual survey, we can select this range. And for the subgrade, it recommends to consider the range of 220 to 100. Now, if we consider this input into the KGB back, it will give us the results, but it will not indicate whether the ball has converged or not. So the back calculated modulus that it will give will look like something. It will give 759 for the BC layer. For the base, it will give 4502. For the subgrade, it will give 99. But if we now put this modulus value into IIT PAVE and measure the surface deflection corresponding to this offsets, what we can measure the deflection ball. So this is the deflection ball that we get, which is shown in terms of M1. So here, what you can see, there's a huge error between these two balls. This is because we have given the different modular range, but which is not actually the condition. You can see it has converged to the lower side of the seed moduli. Therefore, we need to either reiterate this modular value, or even consider a better range of other layers so that we have a proper convergence. So I'm showing another set of seed moduli, that is for the BC layer, the same modular range, but for the base layer, we have given a very broad range of seed moduli from 500 to 10,000 modulus. For subgrade, we have also given from 20 to 200 MPa modulus. What we get is the back calculated moduli in terms of for the base BC layer as 3200. For the base, we are getting around 1445 MPa, whereas for the subgrade, we are getting 110 MPa. We can also measure.
Shubham, you have to conclude. Another 4 minutes.
Yes, sir. Yes, sir. Another 2 minutes. Yeah. So we can even measure the it's the convergence based upon the root mean square error and R square. So by using this approach, we can have a better estimates of the FWD evaluation. So this table shows the results from the 20 FDR packages that we have evaluated. Overall, what you can see, the modulus of the FDR base layer varies from around 1000 MPa to 3000 MPa. Therefore, the relation that we are considering are actually not applicable. We need to consider proper safety factors and then come up with a proper evaluation of this pavement and then come up with proper specifications where we do not either over design or under design our pavements. Overall, what this results indicate that the moduli exceeds the typical design modular that we are considering. That is because we have considered the safety factor of 20%, what we are considering based upon the empirical equation. So this result suggests that the pavements are effectively meeting the structural requirements what was designed for. Now, I would like to highlight that we have evaluated base stabilization under heavy vehicle simulation testing that we did in South Africa. So in this test, what we have done is almost applied a 80 kilonewton wheel load, which is the double of the standard wheel load of 40 kilonewton, but the pavement sustained for almost 7 million cycles. Diesel cycles. And what the results have indicated that the base stabilization showed higher water resistivity and minimal deformation in wet conditions. In South Africa, there was almost 43% of cost reduction. This is because the testing was done on the marginal material, and that's how we could have achieved the economy. So these are the few results that are from the heavy vehicle simulations, as well as you can see the actual rating that is happening. Further, to demonstrate the economy, we have also constructed a National Highway 208 in Tripura, where we have replaced the conventional pavement section with a ZX design, where we have used the stabilized base of almost 340 mm. Here we have reduced the use of aggregates by 60 to 65%. So this has overall led to the saving of capex by almost 10 to 20%. It depends upon what is the cost of aggregates right now in the localized area. Further, we are also working on the stabilization, and we are developing the methods. As I demonstrated, we are developing the fatigue curve for the ZX additives under both dry and wet condition, because wet condition is the most critical, and for that we need to design our pavement, because we need have a 90 to 100 days of monsoon season. So this project we are doing with NIT Warangal. Secondly, we are also working with IIT Dhanbad, where we are doing a lab scale model and also measuring the pavement response in terms of the critical stresses and understanding further the value addition given by the terracil and Zyco board. Also, we are doing a lot of FWD analysis for stabilized pavement, and we are understanding the degradation models and also developing seasonal correction factors, because the current guidelines does not talk about this specifically. Also, the South African guidelines have recognized the value addition by silent base additives, and they have put it into their guidelines for the TRH24 upgrading for unpaved roads. So this is a draft, the first page of the draft specification, and it will be out very soon.
Shubham, you have to conclude, yeah.
Yeah, so just to conclude, the stabilization technique reduces the need for virgin materials and allow use of the existing crust. Water resistant base layer maintain integrity, structural supporting upper pavement layers, and minimize stresses. Suggest implementing proxy lab tests to replicate real life conditions, accessing base strength and fatigue under wet condition. It is important to enhance the understanding of new age materials to improve traditional construction practice. And also we need to drive innovation in materials and method for advancing pavement engineering and sustainability. Thank you.
Thank you, Shubham, for this interesting talk. Before we take up the next presentation, I request all the participants to post their questions in the chat box so that it will enable me to moderate, ask the questions on your behalf, so that we'll get a response from the speakers. I do have a number of questions to be posed to Subham. I will reserve the questions at this point of time. We'll take up all your questions along with my question at the end. Kindly post your questions. It may not be possible to interact one-to-one. So I will moderate on your behalf. If any further clarification needed, we'll discuss that further. So you please post your questions in the chat box. Thank you, Subham.
Thanks.
The second presentation today is on recycling by Professor Dharamveer Singh from IIT Bombay. Professor Dharamveer Singh obtained his BE from MBM College, Jodhpur, MTech from IIT Kharagpur, and a PhD from the University of Oklahoma, USA. He is an all-rounder from A to Z in pavement engineering, focusing on material characterization to design to construction to maintenance to preservation to recycling. So he can be asked any question on pavement engineering. He will be happy, most happier person to answer all your questions. He is closely associated with industry and the highway fraternity. You can, those who are closely associated with LinkedIn can see his postings every day, almost every day, about his interaction with the industry, the lessons learned, and the way to disseminate knowledge to the industry. Here, Dr. Singh was conferred the Pandit Jawaharlal Nehru Bicentenary Award. He has published more than 100 papers. Today, Dharamveer will talk about characterization of wrap, processing of wrap, mixed design, along with the performance. With the recent development in plant technology, he will talk about the quantity of material that can be allowed in the wrap mixes, how the importance of rejuvenator and long-term impact on the life of pavements. He will also talk about coal recycling, which can be done either with emulsion or with foam bitumen. He will talk about the importance of gradation, quality of emulsion, products, production process, and the issues and concern. He will compare the technical issues related to coal and hot recycling. What is Dharamveer? In the next 30 minutes, he can talk about the recycling technology and how to introduce it in a very large scale in the country with the need of that. What is Dharam?
Yeah, thank you, Professor Avi. Very good to see you other side.
Yeah.
And there are so many, keyword that you have given, but 30 minutes, is not something to cover. But I will try. I mean, touch upon some of the points.
Yeah.
And thank you very much for giving wonderful introduction. And very happy to see you. And a very good evening to all the attendees, those who are here. And greetings to all. Thanks to IRF for giving this opportunity as well. And thanks to Akhilesh for giving nice introduction in the beginning. So
it's fine. You can present.
I will just maybe stop the video time being.
Yeah.
So that I can have more concentration actually on that. So Professor Avi, just confirm if it is visible. Yeah.
Wait, the screen sharing is seen. Double click to enter the full screen mode.
Now it is okay?
Yeah, it's fine. It's fine. Go ahead. Yeah.
Yeah. Okay. So I will just use this handle somewhere. It has to go maybe. Okay. So this today's presentation is, I think this first presentation was quite good. And I will just touch upon some of the things. Definitely not possible to cover everything in 30 minutes, but I will give you the key words actually, so that you understand how things are going to go. So there are two things that I will be presenting. One is the hot, another is the cold. And we are going to talk about the recycling. So this is the interest of the topic. So we'll be talking about the hot recycling as well as cold recycling. Just a disclaimer here, there are some of the photographs that I have taken from the open sources, and my intention is not to commercialize anything, but just to give you the kind of knowledge so that you can use it actually somewhere. So we'll be talking about hot and cold recycling. If you see these two samples here, is the sample number 1 and the sample number 2 actually here. And you can also see the color difference. And this sample looks slightly brownish, and this sample looks quite black actually here. And one is hot mix. This is the hot mix here, and this is the cold mix here actually. So this is the typical difference in the beginning itself that you can see. However, with the time, the situation will change actually. Now, if you see, let's say for example, the pavement is constructed, and this is the condition in the beginning itself, and I'm saying time equals to 0, for example. And with the time, depending upon how many years, depending upon maybe months, depending upon the quality of the work, definitely it will degrade with the time actually. And certain distresses will pop up. Maybe it may be rutting, cracking, moisture damage, or certain kind of distresses would come actually. So what we can understand that what you see in the beginning, the perfect condition of the road, and with the time it will decline. But if you see the graphically that how the things would look like, for example, in the beginning, your pavement condition is quite good. So maybe let's say you are giving 100% marks here, and with the time it will try to like deteriorate actually. But quite possible that you may have the different graphs for different kind of roads. For example, you may have another kind of pavement which may start from here and it may degrade like that. That is also possible. That is another way. Or you may have certain pavement which starts and just degrade like that. That is also possible. And it all depends upon the time, what time it is going to degrade actually. So remember, as a pavement engineer or a like agency that you're working on, you are more interested in how do we stop it actually, first of all. And this is a big topic, by the way. How do you really, like what kind of graph do you want? And I'm sure everybody wants this horizontal flat line actually. Nothing should happen once we construct the road actually. But unfortunately, things should not happen like that because there are certain ways or certain procedure that happens and then it will decline the performance. Now, if you see the declination curve, the deterioration curve with the time, and if you decline in this particular range, which is for reconstruction, and I don't think anybody would like to go in that particular zone that you slide down all the way on the down. Initially, the preventive maintenance, that you can do the preventive maintenance so that you save the life of the pavement and you can preserve the life. But there is certain in between, there is a rehabilitation actually. So it means we need to really think about that. How do we rehabilitate the pavement? And a lot of pavements are nowadays getting rehabilitated. Sorry. So this is what happens. So this is the milling activities. Now let's say, for example, this is our initial road condition, which is after certain years, and you have a lot of cracks coming up, and you have to mill it. And this is the milled material. I'm calling it the milled material. And you mill it, and after milling, this is how it looks like. And then you bring it to the plant, and this is how the material looks like actually. So this milled material, we call it wrap. Recycled asphalt pavement. This is a wrap, and you are going to hear a lot about this wrap mix design, and all kind of things. So remember that the particular definition that you are going to use it actually later on. Now, this is a well-known fact actually. So worldwide, if you just take out the kind of material which is 100% recyclable, and you are going to see the bitumen mix is definitely 100% recyclable. You can use 100% recycled material into the pavement. Now, there are many benefits. I'm not going to look into all these things, but definitely this is what it comes out the most actually. If the cost saving is happening, I'll be using it. Now, environmental sustainability, like all these buzzwords are there, but the first foremost issues or first foremost eye catcher is the cost actually. Is it going to save the cost or not? If you say yes, we can use it. That is how the perception is actually. And not only in India, but all over the world actually. This is how it is all about all kind of technology, whatever it is. If the cost saving is there, the next question comes whether it is going to be sustainable or whether it is going to really give me the good performance of the road or not actually. But yes, I think you can recycle the material 100% actually. Now, recycling, when you talk about, I'm going to classify in the two terms. One is the cold recycling and another is hot recycling. The cold, definitely there is a temperature is less. Why I'm saying less? Because there are certain technology, for example, foam, asphalt and all. Hot recycling is like you are going in a different, slightly higher range of the temperature. Hot recycling, cold recycling. Now, we're going to talk about the hot recycling first. What is the hot recycling? Now, hot recycling, you can do hot in plant recycling, for example, or you can do hot in city recycling. Hot in place recycling, and on the spot we are doing the recycling. or you bring the wrap material, whatever the wrap material is there, you bring onto the plant and then you process it actually, and then you start using it, or you do on the site itself. How do you do that? Remember, there are some project has happened in India, for example, in-place recycling, but there are certain challenges with these particular techniques. The machineries and then type of the variability that you get into the material, and you cannot go larger depth of the like the layer, because there are certain limitations that how the machinery or the machine can really melt the material. But hot in plant recycling is a worldwide quite popular and most popular technology that you can think about actually. And you can go up to 60%. There are a couple of projects this has happened in India where the people have gone even up to 60% of the wrap. And this is how we need to talk about that. What kind of ingredients are there? What kind of materials are there that we can think about actually? These are the general query that I see actually. Can I do that, first of all? And we have seen many contractors, they are really having so many questions sometimes. So first of all, the question is, can I use it? Can I use the wrap? And if you say yes, then another question is started. If you say no, then the job stops there itself. Can I use the wrap between DB and BC? Another question comes up, because you say the IRC does not allow in the top BC layer. Can I use in the DBM layer? What is the percentage that I can use in the DBM layer? What percentage I can use in the BC layer? So all these questions are there actually in the mind of the agency, whoever the agencies are actually. Then the question comes, the regenerator. Do I really need to use a regenerator? If you say yes, what type of regenerator? If you say no, it's okay. But you need to know about that actually. Another question people fear, the agency, I have seen a lot of kind of negligence, or you can say many people really fear that mixed design of the wrap. Can I really do the mixed design of the wrap? My team is not trained about it. How do I do the mixed design? What kind of changes do I need to do? What kind of process that I need to follow? Another question, things that we have seen nowadays, the plant type. I have this kind of plant. Can I use up to 50%? I have this kind of plant. Can I use up to 40%? Or sometimes, in fact, people have gone up to 60% with using a regular plant. But remember, this is not simple mathematical calculation that you can add 35% coming from the in the pug mill, and 15% is going in the dry drum, and then altogether you are using 50% wrap. This is not that kind of calculation that you can. And we have seen a lot of people are thinking about this kind of calculation. If 35% is going in the pug mill, 10% I'm putting in the dry drum, so altogether I'm using 50% wrap. That is not the kind of real advantage of using the wrap actually. So this is what you need to be very, very careful, that what kind of process that you are following. Another question is, can I do the in-place hot recycling? What machinery is going to be useful? What are those machineries? What kind of cost is there? How helpful it is going to be? Whether it is going to be successful or not? That kind of things are there. And then finally, whether I'm going to save the cost. If you say yes, how much? And what kind of confidence level that we have. These are the steps that we usually follow. Once you need to collect the wrap, and remember, this collection is not just collection of the waste material actually. You need to be very, very careful that what is your procedure of collecting the wrap. It is not just taking out the JCB, digging out everything and pulling that somewhere and then dumping it and then you say this is the wrap. That is not really you are going to get the complete benefit of the wrap. So milling procedure has to be very, very careful. What kind of quality of the milling that you are using, that is also very, very careful. Once you bring all the wrap onto the plant, and I'm going to show you a couple of photographs later on, the important thing, in fact, I would say the most important thing comes the processing of the wrap. And I have not seen many of the contractors are really following this processing of the wrap actually. They assume that whatever material has been collected from the site, whatever has been dumped into the plant, that is the wrap. But remember, you have to use the kind of processing. When I say the processing, there is 2 steps. One is the fractionalization. You can make it coarse wrap or fine wrap, because that will give you a lot of better result, homogeneous mix, and good confidence level actually. Or sometimes there is a procedure you can also do the homogenization. You can mix things together and then make sure that you are avoiding the variability into the wrap material. So those are very, very important. Then you have to understand the wrap, what kind of wrap is there, where I need to use it, which layer I need to use it, I'm milling the DVM and can I put in a DVM, or I can use some percentage in BC also? What kind of plant that I need to use? What kind of rejuvenator that I need to use? What is the coarse rep and fine rep? What kind of dosage of the rejuvenator? And then you monitor the plant production. Remember, the mix design itself is not your final job. If you think that somebody has given you the mix design of the rep and you can 100% confident on that, then you are doing some mistake actually. Your job is to ensure that whatever the plant is producing the rep or the mix, that satisfy the quality, not the mix design actually. Mix design, somehow it will come. So this is how the stockpile look like. For example, this all rep material is here. And when the rep material comes, this has a lot of like variability. If you take one sample from here, you may find certain gradation, certain binder content. If I take one sample from here, you may find something else. If I take one sample from here, something else. How many samples do you want actually? Maybe 5 samples, 10 samples. Or there's other ways you can really avoid a lot of variability into the rep if you can do the coarse and fine rep. Let's say, for example, if you see here, this is your coarse rep, and if you go this side, this is your fine rep. Now you have much better control actually. Now you really have the consistent, the kind of mix or consistent rep, which is coarse and fine. And then you can use certain percentage of X, certain percentage of the fine rep, let's say X percentage and Y%. And you have the better control on the gradation, on the quality, consistency of the mix, and definitely the kind of what kind of saving that you're going to achieve actually. So the first step that people need to really follow actually, if they wanted to use high percentage of rep, 35, 40, 50, 60, whatever actually. Second come the characterization. And here what I have seen, the characterization, some people think that this is a complicated task actually. And it is a very difficult task. What do I do? Why do I do actually? And remember, the rep has a very stiffer binder because the binder becomes quite stiff with the time. It means the softening point will increase, or viscosity will also increase. There are many approaches are there actually. In fact, you can use very simple approach of using softening point. Many of the countries still use a softening point approach actually. You extract the binder, do the softening point, and try to understand what kind of quality of the rep is there actually. Whether the rep is really very stiff, or you need to use certain kind of rejuvenator, or what kind of treatment you have to do actually. So that definitely the role of the rejuvenator comes with the type of the rep that you have. For example, one of the rep, let's say, for example, I'm showing the example here. If you see the softening point of this rep is 80, almost 80 degrees Celsius. And if you see the penetration is around 5.7. Looks like this particular rep is quite stiff rep. Now, how much percentage that you wanted to use? For example, you say I wanted to use 30%. Or you say, no, I can use maybe 50%. Then you have to be careful here actually. Because the rep has a stiffer binder, it means this is also going to give certain kind of, like the kind of performance issue. I will show you that what kind of issues can come up actually. So you have to be very, very careful that how do you characterize it. Now, another thing is the rejuvenator. Now, if you increase the percentage of rep, for example, then the situation would arise that you definitely need to think about rejuvenators. You can think about it will, like help you to modify the chemical characteristics or better performance or the durabilities or a lot of things actually. There are many rejuvenators in the market, many rejuvenators. And not all the liquids are rejuvenator. Remember that. Whatever liquid I give, I can, when you are adding any liquid into the bitumen, viscosity will decrease anyhow actually. So there is not magic kind of thing which is happening, it will decrease. However, your job is to ensure that what kind of impact the rejuvenator is going to have in the long term, and which we have to really think about. And this is one of the very interesting paper. If you see, there are different kind of rejuvenators here, different kind of rejuvenator. And if you add the rejuvenator dose here, for example, 0 to maybe 24%, and this is your penetration, definitely penetration will keep on increasing. Now you see the dosage of the rejuvenator. If you are using this particular rejuvenator, your dose is like up to here. If you are using naphthalene-based rejuvenator, your dose goes maybe is like it's never going to achieve it. So type of the rejuvenator, impact of the rejuvenator is very, very important. How do you assess that actually? Now let's say this is another very interesting the findings. You have different kind of rejuvenators, and the PVM is higher is the better. It means When you add the rejuvenator in the plant, what happens? There is a lot of heating happens. Heating going to happen during the production and then transportation. A lot of heating is going to happen. Quite possible your mix may become maybe highly aged actually within the no period of time. So you wanted to make sure that whatever rejuvenator you use, that is not giving you the adverse impact on the performance of the mix actually. Now, higher the value, better is the mix. But if you see this kind of rejuvenator, they are creating certain kind of problems into the mix actually. Another thing is the rating value, and I will show you very interesting findings on the rating. You have a different kind of rejuvenator, for example, rejuvenator 1, 2, 3, and 4, for example. And all are well established. They are all are claimed to be very good rejuvenators. You have decreased the viscosity, your job is over. However, when you go to the performance of the mix actually, when you do the performance, long-term performance, and then you see the certain kind of different result altogether. All the rejuvenators were very good in the beginning. They showed excellent result. However, when you do the performance test actually, and then you realize that rejuvenator 1 is going to backfire you. It may make your mix so soft that it will going to 100% rut within no period of time. And if you use rejuvenator number 4, definitely you are going to see that it is providing the better kind of performance, and there is a rutting is a less issue. One thing is the rutting. Other thing, what happens actually when you use the rejuvenator, the cracking becomes another issue actually. It should not happen that your rejuvenator becomes quite aged and then you see the problem actually. Therefore, the cracking also becomes quite critical. And if you see this result here, higher the better value. If you see this particular rejuvenator, 2 rejuvenators here, they are performing very good. But if you see the kind of WEO and the wax, it is performing very, very kind of not really expected as we think about actually. So there are different kind of rejuvenator. Organic blend is there, refined tallow is there, paraffin oil is there, aromatic extract is also there, and there are different kind of the kind of chemistry that works out, and then this is going to give different performance. Therefore, you have to be very careful that what kind of rejuvenator, how do you really monitor the performance. So this is how the kind of summary of hot recycling. Processing is very, very important. Stockpile the wrap, protect the stockpiles actually. And remember, when the milling happens, a lot of moisture also comes into the wrap. So you need to account for that. You cannot dump maybe 30 to 40, 35% of wrap directly in the pulp mill, because this particular wrap has maybe less than 3% moisture in that. And this is going to create the problem. You have to bump the temperature maybe around 180 degree or 185 degree. And then you have to evaporate the kind of wrap moisture, as well as you have to indirectly heat the wrap. You have to be very careful that what kind of characterization, what kind of plant, what kind of processing, what kind of combination, what kind of coarse and fine wrap combination that we are trying to use. Establish the mix design, check the performance. Once you are satisfied on that, then your job is almost 80% done actually. Now you have to fine tune your plant production, which you are already mastered in actually. But only thing is when you are using wrap, the plant production becomes slightly tricky task because the wrap has to be heated actually. Either you have the parallel drum plant, which is people are using nowadays for the high percentage of wrap, but the cost of those kind of plants are slightly on higher end. But I think there are a couple of sites people have used those kind of plants now actually. And we have been picking up in that particular area. So this is the future. This is how we have to go actually. Now comes the cold recycling actually. In the cold recycling, and if you see, and I already showed you this kind of 2 samples. This is the cold, this is the hot here. If you break them up, this is how the things look like actually. And again, we usually people ask a lot of questions. So what is cold recycling? How much percentage of wrap can I use? Can I do the emulsion or can I use foam bitumen? Which one is good? Can I go for whatever the emulsion I have, or can I use whatever the bitumen I have in the foam as a foam bitumen? Can I do the recycling in the plant? What kind of plant is required in situ? What kind of in situ machinery is required actually? And I will show you a couple of interesting in situ machinery nowadays which people are using. How do I do the cold recycling mix design? Remember, this is the kind of the link that we have been trying to improve upon, because the approach that we have been using, it's not really applicable sometimes for the heavy traffic loading condition that we are going to discuss about it actually. What precaution has to be taken? There are certain failure stories for the hot recycling as well as cold recycling, but it doesn't mean that the technology is bad, or it doesn't mean that you should not use it actually. There are always ways to learn, there are always ways to improve upon actually. This is how the, let's say for example, your pavement look like. And either you can think about in-plant recycling, or you can think about in-situ recycling. Now, this is how the things look like. You have the emulsion, you have the foam bitumen, you can do in-situ also, you can do in-plant also. And you say the in-plant, you mean you can do the full central plant recycling. You can have the dedicated plant, and there you can do the recycling, or you can have the in-place recycling also actually. Some people call it that kind of mix as a BSM mix, bitumen stabilized mix, and some people call it cold recycling mix. So it's up to you, how do you really want to understand it. But emulsion and foam actually. Many people prefer emulsion is better, but some people say that foam bitumen is good because you don't require any kind of curing in that. You just kind of construct it and use it. In US or maybe some part of the world, both of these techniques is quite popular, foam as well as emulsion. These are the ingredients in the cold recycling. You have the wrap. Again, wrap is coming, and you can use up to 80 to 100% wrap in the cold recycling. Whatever the wrap you have, you can definitely use it actually. You have the water, you have the fillers, and then you have the emulsion here. You compact the sample, prepare the sample. And remember, these samples are going to have almost 8 to close to maybe 12 to 13% air voids. A lot of voids are there, remember. So once you construct this particular layer, you need to be very careful that you protect it actually further. Otherwise, it is going to have a lot of raveling issues, or it will absorb a lot of water with the time if suppose there is a rain actually. So you have to protect it. It is not the top layer, remember that. It has to be protected with some kind of overlay. Either you put DBM BC or BC or maybe any other overlay that you have to put up actually. So that we have to think. This is how the MIG design happens. And this MIG design is well established. People do ITS value that 225 in the dry condition, wet condition, 100 actually. But what we are thinking that these particular ITS values are not going to tell you all the story about the mix. You need to again rely upon what kind of performance of the mix look like. When I say performance, it means the cracking. For example, if you add too much filler in that, it will crack. Or what kind of rutting performance? Can I use that particular layer on the top layer somewhere? Maybe let's say close to within the 100 mm or so. If so, what kind of performance do I want actually? Now, this is how the cold center recycling happens. You have the milling machine. Again, remember the processing is again very important. So it's not like you can use the cold recycling and forget about the processing. Its steps remain same actually. The wrap processing or wrap factorization, it remains same. Definitely, you are not very much concerned about the bitumen content in the wrap, but quality of the wrap you are concerned about it. What kind of coarse wrap, fine wrap, how do I adjust the gradation actually? Then you just bring it here and then you pave it, and this is what you kind of construct it actually. I will show you a couple of advancement nowadays is happening in the cold in-place recycling. And this is very much required nowadays in India also. One is a single unit train, then it is 2-unit train, and there is a multi-unit train. Single unit train is just one machine, only one machine that we have. There is no screening, no crushing actually. Whatever is happening, like nowadays, a lot of projects are going on the single unit train. One machine is everything is done on the site. 2-unit means you have the paver now in that. And this is very much required because when you are doing the milling or in-situ milling, if you have the paver, you have the better control on the thickness and uniformity in the compaction and then homogeneous mix actually. Other train nowadays coming, or other the machinery is the multi-unit train. On the site itself, you have the crushing also, you have the screening also, you have the pug mill also, you have the paver also, and then you just keep on doing. I will show you some of the photographs actually. This is the single unit train. You have the single machine which is doing everything in that. Remember, there is no control on the gradation here. There is no 100% surety that you are going to get the homogeneous mix all the time. There may be certain variability here, there, certain places. Thickness control has to also be there. It may not be 100% uniform thickness sometimes. And there are certain kind of, like a quality issue may come up actually. So this is the single unit train. This is your twin train. What is happening in the twin train, you have the milling machine here, you can see here, and you can see the paver. This is the paver here actually. Whatever the milling material is coming up, it is going to the paver, and then paver is going to pave it actually. So in one way, you have slightly better improvement from single train to the here. But Remember, we are not doing any screening. There is no gradation control. Whatever is happening there actually. But it is such slightly better than the first one. This is quite popular in many parts of the world, and it has everything in that actually. You have your milling machine here, then you have the screening unit here, and then you have the paving also actually. So there are a couple of things which is together. It is going to mill it, screen it, grade it, throw out the larger material, and then mix it together, and then giving it to the paver, and then you pave it actually. And many people have used this kind of approaches nowadays actually. And in fact, many people are also doing like combination of the layers nowadays. Maybe in-place recycling, cold recycling, then in-plant recycling. That is also possible. For example, if this is your pavement here, and what you do, this particular layer can be in place, cold in-place recycling, or this layer you can do cold central plant recycling. That is also possible nowadays. In fact, people are doing that. If there is depending upon the project type, actually. So you can do the combination of the recycling. This is how the things will play. In fact, FDR is also been done using emulsion. In fact, we have seen if your aggregates, if your layer, for example, if you have the bituminous layer here, if you have GSB or DBM and BC, and if you are doing FDR, and when I say the FDR, I'm not considering really your subgrade and all. If you can going up to WMM, let's say, for example, you can easily do your FDR using emulsion and like any cementitious additive. That is also possible. You can use emulsion, you can use foam. In fact, many of the projects in US and some countries, they are using emulsion for the full depth recycling actually. When you have a lot of aggregates into the layers, definitely emulsion and foam this additive can be used. When you have a lot of soil, for example, and then maybe 60 to 70% soil, or maybe 40%, 50% soil, that time you have to think that what kind of additive has to be utilized actually for the construction purpose. So this is another the way of doing the FDR technology that people are using nowadays actually. And with that, I will thank you, Professor Avi, for giving the opportunity here.
Yeah, that's a good presentation, DV. I think you opened up many issues of concerns. You showed how hot in-place recycling and central plant recycling, as well as cold in-place recycling and cold central plant recycling are different, and what are the needs. And I think let us hear from the participants of other questions. I think those who have some doubts and clarifications, kindly post under the question and answer. We'll take it up. Let me first take the questions posed to Mr. Shubham, and then we can come to Dharamveer. Shubham, the first question they have posed is that whether the lab UCS value is 1.1 times or 1.5 times the specified UCS.
Right now, the practice is to consider the 1.1 times, but I think in IRC 37, there is some clause which mentions 1.5 also. But right now, 1.1 is recommended.
That is fine. I think this is where I also have got an issue with you. So everywhere you're referring to IRC, this is mentioned in IRC. But what I expect from you as a researcher is that this is what I got in the lab, this is what I'm getting in the field. Therefore, IRC value should be modified like that. Will you be able to come out like that?
Yeah.
Have you tested lab samples? And then for the same lab mix design, have you tested the field samples and then found the relation?
So we are working on those lines.
Yeah, that is what is needed now. Yes. So in all your presentation, you're told that UCS value empirical is not correct, fatigue equation is not correct, FW back analysis is not correct. But what we expect from the researcher is that how to make it correct. What should you do? So this is one area where you should come out with a finding as what should be the value between lab to field. Remember, there will be a wide variation between the lab to field. Even within the lab itself, when you do, there will be a variation. So consider the variation and then come out with a number.
Yes, sir.
Okay. So the second question is that how the samples of the field UCS and lab UCS is made for determination of the strength. Supposing if you have taken up the sample from the field, will you compact the sample to the field density and field moisture or to the YMC and maximum dry density? What is that you do? Have you done it?
We'll do at the density we are achieving in the field. So there would be a huge variation because we need to maintain the moisture plus minus of 2%. But actually the based upon what we are doing in the field at the same density we should compact and then measure.
That's why I'm telling there will be a wide variation. The soil
Yes,
will vary.
yes.
Everything will vary. Density will vary, and hence your modulus value, thickness, design, everything will vary.
And will vary. The coefficient of variation that we are observing is almost more than 30%.
That's what I'm
So
telling.
it's
That's why
high
how
variation.
to minimize that. So that is something that you need to study.
Yes.
The other is that have these additives used for high traffic roads like natural highways. Please provide the performance experience for high MSCA like 100 MSCA. Also elaborate how old performance evaluation details are available. Do you have any performance data on those road sections stabilized with your Zycosil, maybe all your products? Do you have any performance results? That's all they are asking. Zycobond, Terrasil.
Yes, right now in my presentation, I showed the few of the FWD evaluations that we are doing.
There only, I think, Shubham, whenever you make a presentation, you showed some photographs. Yes. But we do not know what are the layers that have been stabilized, modified, what dosage was used, what the traffic level, after how many years you are showing the performance. Nothing is available in that. So,
so it was available after 3 years.
No. That's what
pavement composition was not there, but the time was there. Yeah, I can provide the details.
Listen first and then answer. That is the question posed by Naveen Goyal. Okay. If your presentation had all these details about the soil type, composition of the pavement, which layer was stabilized, what traffic level, after what age the performance are shown, what the performance, that's what Naveen Goyal is asking. So in your future presentations, consider these aspects and then show the results. Okay?
Sure, sir.
Yeah. The other question, the other question is from Oja. On the FDR construction, how the gradation will be controlled? What is the gradation that you have considered? Is it the CTB gradation, or is it the FDR gradation given in the IRC code, or what is the gradation that you have considered for the FDR?
The gradation that we are using, it is a CTB based gradation where we have a huge band that mod specification allows. So if we do the gradation, we have a huge variation that we can observe, but more or less the gradation will fall within the band specified by the mod specification. It is table 404. Okay.
The other question, I think these are the questions I think will come to Dharamveer. But before that, a few more questions. Have you studied the resilient modulus of these stabilized mixes?
Yes, we
What are those numbers? But you have not, you are told about the empirical equation, but what are your numbers? How different are they?
Yeah, the modulus will range from somewhere 2000 MPa to around 4000 to 5000 MPa, depending
upon... Here again, Shubham, you have to consider that these materials will undergo change, you said, with moisture. These materials, when they are stiff, they are likely to crack. Therefore, the value that you are getting in the laboratory without any fatigue test will not be the modulus, should be considered for the design. That's why we consider some conservative values.
Yes.
So based on the field course, supposing if you test the resilient modulus, do you have the numbers?
Yes, sir. Even the field course we have taken, and also those are in quite good relation with the FWD evaluation. The numbers vary from somewhere 1000 MPa to 3000 MPa.
There again, I have a question. I think I did not ask both a question. Why are you said that you have the Terrasil and Zycobond, which add to the strength? Why are you adding 4 to 5% cement to this?
Because this additive goes in conjunction with the cement. So cement actually gives the initial strength, but the water resistivity and enhancement in the fatigue that is given by the
your claim is that it increases the strength.
Yes.
It increases the modulus. Supposing if I do the stabilization with your Terrasil and Zycobond, what number you will get?
So we get almost enhancement by, let's say, without any additive, if I get a CBR value of around 5%, and with Terrasil Zycobond, it can go, it takes time to achieve a good enhancement, but it can go up to 20 to 30 CBR also. But that needs proper consolidation and the curing time period.
That's what these are the research needs.
Yes.
So see, when I can as well go with cement alone. I don't need your cycles.
We can go actually.
I can do.
Yes.
So
Yes.
again, because why I'm asking is that the cost goes up.
Correct.
Is it worth investing that money? What is the life cycle cost? What is the performance? This is what the question everybody is posing.
Yes,
So
sir.
I would like to see road sections constructed without cement, with your terrasil and the bond alone, and see the performance. And if it performs, I do agree. Yes, it will perform. I agree that.
Yes,
But
sir.
still, I'm not very much convinced that it will increase the strength by from 5% to 20%. Again, in your presentation, you have mixed up with the soil, CTSB, stabilized subbase, stabilized base, and full depth reclamation. All the four are
Yes.
different animals by themselves. So don't
Yes.
mix up with all the four. Do one soil, how the soil characteristics can be modified with your terrasil or zycobond. How
Sure.
cement treated subbase can be used. Yeah, as you know, cement treated subbase should also serve as a subsurface drainage layer. So how does the subsurface drainage of the layer which has been added with zycobond? This is something that I would like to know. In the case of base courses, how does it perform? These are other issues and concerns. And again, IRF does not say use back calculation software adopted by them. You can use any software. We don't say that you should do only that. So finding fault with the IIT software is not correct. Either you should come out with your own software, use any international software, or use any other deflection ball indices to come out and relate it to the performance. That is what something we expect from these research talks. Finally, because I am a member of the Specifications Standards Committee, I listen and attend to these talks so that it will enable me to introduce some modifications based on your research findings. So instead of finding fault with the IRC codes, come out with the research findings, publish this as a paper in the IRC, we'll discuss it, and if found suitable, valid, we'll incorporate that in the next revision of the codes. So I wish you all the best in your research,
so
that we can take it up further. Thank you.
Yeah. Thank you, sir. Thank you for the valuable feedback. Yes.
Dharamveer, there are many interesting presentations. Many have appreciated your talk. One of the question which is posed is that, is there any expiry time for the milling material for using as a wrap?
Yeah, thank you, Professor AV. I'm ready for the Viva. So, a very interesting question. I mean, is there any expiry date for wrap? I mean, whoever asked this question, I think I mean, good question, but we don't talk in terms of the expiry, but we say
you can consider in terms of aging. You consider that in terms
you can think in terms of the aging. Yes, aging will happen with the time, and definitely the characteristics will change. So whoever asked the question, please learn the terms like aging actually, because like that will be more appropriate. But aging will happen with the time.
Okay. The next question is that what should we do by incorporating a wrap? We are getting a low performance of the sample.
So this is, I think, whoever asked this question, they are definitely struggling with that MIG design actually. And quite possible there are certain steps they may be missing in the kind of either gradation or batching the mix or sampling the mix, or how they are adding the rejuvenator. I'm not sure whether they're adding or not. But otherwise, if you do the proper MIG design, wrap mix gives very high stability actually. And that is the beauty of using wrap. But maybe if there is a rejuvenator or there is some higher dosage of something, definitely it may backfire. So please look into your MIG design, what kind of approach that you are using, what kind of gradation that you are following actually.
The other thing is that a suggestion is that if you have shown a flow chart of the design, perhaps this question will be answered as what they should do if it is not meeting the requirement. The other question is that how is the aged binder recovered from the wrap and characterized here? How do you characterize that?
I think it was, I quickly skipped that slide. There is a, I mean, you know, but for the audience.
I'm audience only, they're asking, I am
yes. So there are a couple of techniques, but the best way you can use a rotary evaporator. It means you extract your mix and solvent, and then you again extract the solvent out of that. So we call it rotary evaporator actually. And it's quite widely used. And if you can connect me back, I can share you some of the photographs or some certain kind of videos so that you can look into that actually. But it's well established technique, fairly kind of well accepted by the industry also.
A connected question is that how we consider the viscosity difference of the bitumen of the wrap and the new bitumen in the design of the mix?
I think this is very interesting question, Professor Avi, because what is happening, I'm really losing interest on the viscosity of the wrap binder actually. Because the kind of variability that we are getting into the measurement of the wrap viscosity, wrap binder viscosity, there is a high range of variability that you can see from one lab to other lab. So I would suggest instead of viscosity, please follow the simple tools. For example, you can also, like other countries, they are using even softening point for the rejuvenator actually, or for the wrap binder make design actually. So definitely variability will come in the viscosity, because if you are using this absolute viscosity 60 degrees Celsius, it's very difficult to do sometimes for the wrap binder actually. So I'm not really a good fan of the viscosity measurement for the wrap.
Yeah, I think that's a question to Shubham. What are the tests conducted for the stabilized layer in the performance tests? What are the performance tests that you carry out on the stabilized layers?
So we do the FWD evaluation right now in India, but
No,
in
can
order
you
to
do
be,
any laboratory fatigue test? Any performance study? That's what he.
yes, flexure strength, flexure modulus, fatigue testing we can do.
The other question is that how to retain the gradation parameter using high quantity of locally available material as per the MOH. The gradation may vary. If so, how do you stabilize? But this again comes to the variation. The material
Yes.
as collected from the lab, from the field when we tested in the laboratory. Other question to Devi is that what is the maximum percentage of wrap which you would permit in the DBM or the BC based on your experience?
Okay.
Because we have some 20% and 30% we are permitting,
Right.
but 60% also have been used by Cube Highways and others. But what are your recommendations based on your experience, the maximum percentage of wrap that can be used in DM, DBM, and the BC layers?
Okay. So when somebody asks me this question, I ask them one question: what kind of plant do you have actually?
Okay.
So because it all depends on the plant. And if your kitchen is not well equipped, you cannot utilize it. For example, let's say, for example, some people are using 60% of the wrap in the DVM, and in some country even 80%. But my experience in India, the kind of majority of the plant that we have, if you really want good confidence on the mix, I would suggest is 30-35% is the limit that you can think about actually, depending upon the majority of the plant. But if you really wanted to go on the upper side, then you have to change the plant actually. So that is the one thing in the DVM. BC, I'm not really going to the 30-35% because the processing is also very important. So 15-20% you can definitely think about in the BC also. And in fact, we have used that on some of the site actually, even up to 15% in the BC we have used. So remember the basic rule is processing of the wrap, fractionalization of the wrap, and the plant operation. And if you are really synchronizing that, so comfortably you can use 30% blindly into the kind of DVM, but with procedures actually.
Yeah,
that's what we have to do. Yeah,
that's correct. See, the problem is that the technology gets a bad name.
Yes.
If it is not processed final as per the specifications. Yes. We mix something and something 30% just like that without fractionalization, without homogenization, and then we find a fault with the mix design and the performance. So unless you do your homework properly, the wrap mix cannot perform well. It can perform well if and only if you follow the specifications of mix design. As per the ministry also, we are now proposing 20% maximum in the bituminous concrete and about 30% in the DBM. Higher can be used, but at your own risk. Someone has asked about the, I think Samangada has asked about the blending chart with the softening point.
Yeah, right.
Yeah.
I think I know him actually very well, and definitely they're working a lot on the wrap.
Okay.
And so it's like straightforward actually. I mean, you have the wrap binder, the wrap binder is giving softening point, let's say 80 in our case, what we see. And you add maybe, let's say, do the blending 35% wrap and maybe 65% virgin binder, and check the softening point again, and then see rejuvenator doses and then softening point again. It will give you the initial good starting point actually. It is not bad approach. It will give you a good starting point. If you wanted to further validate that, in fact, that this is what we are doing right now, we are also going to the super PG and all, but usually practitioners are not going to follow that approach actually. So we are simplifying the thing, whether softening point or penetration or any other approach can be used, ductility, for example.
There's a question. I think he is asking about the phase diagram of the RAP samples. Perhaps that can be a different issue. Then there is another question from Kamal Gandhi. We have used around 55% RAP in in-place recycling under the guidance of Dr. Sunil Bose and Abhishek Mittal here in Delhi with Virgin Mission, and performance was excellent. I think I don't know how many months, years are over. It's maybe too early to tell that performance is good. Both good and bad are there. Like, you should be able to tell the performance after how many years and what traffic condition is performing well. If saying it's performing well is not a correct answer, you should be able to quantify that. I think I think these are the questions. I have just one quick question to Dharamveer. Dharamveer, this IRC 17052 talks about rejuvenators. Now, these rejuvenating agents are RA25, RA100, RA400.
Yeah.
How do I decide which RA will work and how to go about it?
I think the very pertinent and like hot questions you have asked, because I have seen, in fact, 5 years back, there was 1 or 2 regenerator in the market.
Right.
And right now there are maybe I can count maybe close to 10 to 15 regenerators.
Right.
And different kind of bottles, different kind of colors.
Right.
So, but the question comes, in fact, contractor has no idea actually sometimes.
Right.
And they are going to pick whatever regenerator the so-called is going to give the less cost.
Right.
So your question is very valid, that how do I select the good quality of regenerator for my particular application?
Yes, exactly. Exactly.
And in the simplified way, actually, so that I can check on the plant.
Yeah.
And that way, I think right now, I would maybe 1 or 2 hint I can give. If somebody is using the regenerator, if they can do the long-term aging for the mix, for example, maybe let's say, like slightly, maybe 4 hours, 10 hours, 15 hours, or maybe 5 days, and check what kind of durability issues the regenerator may cause actually to your mix.
Okay.
So that is possible. And also the rutting may be the kind of issues that is possible actually. And some of the regenerator process we have seen, what happens when they are injected into the pug mill, they create a lot of fuming actually, a lot of like foam gets generated. And that way their effectiveness in the lab maybe looks very good, but in the plant they may work altogether different actually.
Right.
So I think we have to do a lot of work on that actually.
And in your presentation, you made a mention that in case of high RAP and too stiff RAP, you need a regenerator. Can you quantify what is that? How much is too stiff and high RAP?
Very good point actually. In fact, many of the RAP that we are getting in India, they are not very stiff sometimes actually, because many of our highways are like 2 years, 3 years, 4 years, 5 years coming up. So if suppose, for example, in my opinion, if suppose your RAP is having softening point, maybe let's say close to 80 degree or 85 degree, definitely you can categorize that in the stiffer nature. But if it is softening point around 65 or so, it's not really very stiff RAP actually. Anyhow, naturally your VG40 will also give you close to 52 or 53 actually. And there is a fines also in the RAP. Because you cannot exclude all the fines. So softening point will naturally increase up to 58 or so actually. So until unless you are getting softening point as high as maybe let's say 80 or 85 or maybe more than 75, it's like a stiffer RAP. But now comes the quantity of the RAP.
Yeah.
The quantity of the RAP is around, let's say maybe, for example, as per the literature, they say more than 35 or so. But I'm not really very good in the agreement with the kind of literature that they are giving, that less than 15% don't change it or change it or whatever. I think we need to do our own homework actually. What kind of RAP quality we have, because in the US and all, they have the very stiff RAP. Their RAP is coming after 15 years. Our RAP is coming after 5 months. I mean, a couple of years actually.
No, months so also.
We cannot rely on those parameters actually.
Yeah.
So your questions are quite practical questions.
The other question is that when we have different binders, VG30, VG40, PMB, plastomer, elastomer, we have the what is that? CRMB of different strength, 50, 60, and all we have. When you have a cocktail binder, when you extract, how do you characterize the material and use it? We have even a gap grader rubberized bitumen also recommended for a very high traffic.
Yes.
How do you recycle these mixes with all these cocktail binders?
Yes. I think we have done one very good study where we have used this RAP with PMB binder.
Okay.
And you're not surprised that RAP using with the PMB binder, your PMB itself doesn't perform well, because whatever quality of the PMB was there, it suddenly deteriorates actually.
Right.
though it looks very lucrative that you can use with PMB and you can save the cost, but anyhow it is backfiring you actually at the same time. So there are certain challenges, but yes, I think we have to find maybe technology has to go in a kind of, we have to do the advancement, but there is no defined answer that like you can 100% sure on that.
This is because the ministry has issued a circular saying that you should use only VG40, even high temperature and high traffic condition, or use a gap graded rubberized bitumen or CRMB. They have specified this shall be used. So you will have more and more such mixes for recycling in the years to come. If so, how do we characterize these mixes will be a real challenge. They used a different binder in the binder codes, upper binder, lower binder codes, and the wearing codes.
I think my way of thinking would be like that. We should get rid of these extractions and all.
Yeah.
We should really talk about the wrap quality itself, actually.
Right.
Okay. And forget about the extractions and then what is happening. Let's talk about wrap mix, blending, and then see the kind of property of that itself, actually. I think that would be the approach that we have to think, actually.
That I think we have to give a little clear approach for the field engineers. And one last question is about, have you recycled stone matrix asphalt mixes?
No, we have not recycled, yes.
I think that is again the need of the hour today.
Yeah, right.
So your Mumbai-Delhi Expressway itself has started premature failures of SMA layers. So what to do with that? So this is something that we need a little more thoughts as how to recycle SMA mixes again with polymer.
So SMA mixes you're talking about. I thought maybe SMA mixes you're talking. Recycling.
Yeah. Yeah.
Okay, got it. I think those SMA mixes are not SMA mixes actually.
I don't know.
No comments.
No comments.
I know, but I'm just kind of.
But that's why I'm telling the technology gets a bad name because of a wrong constraint practice, wrong quality control. So it may not be SMA as per se, but they call it SMA. So they use the fibers, they use some polymer modified binder, they laid, it has prematurely failed even on expressway.
Yes.
So now they say SMA has failed. They don't admit that SMA as laid is not SMA.
Yes.
So these are issues and concern. The quality comes into picture.
Yeah.
So I think it's time. I think it's both Shubham and Dharamveer have opened up a lot of thoughts. I think number of interesting questions posed from the participants. So I take the opportunity to thank both Shubham and Dharamveer for sharing their experiences. It's not the end. It's only the beginning. We'll interact further in many more events. So I take the opportunity to thank IRF India chapter for giving an opportunity for me to moderate and Shubham and Dharamveer to present their work on the stabilization as well as on recycling. Thank you very much.
Thank you, Professor AV, and see you in IRC.
Yeah, sure, definitely. Yeah.
Thank you, sir. Thank you very much.
Thank you. Anyone from IRF is there? I don't know.
Yeah, thank you. Thank you.
Yeah.
Thank you, Akhilesh. Thank you very much for taking this initiative. Thank you to IRF.
Yeah.
Thank you, everyone. Thank you very much. We will meet again.
Yeah, sure. Yeah. Thank you very much. Yeah.